today in this video, we are going to be doing Calc AB Problem Set 49, and the problems and a playlist are in the description, and let's go. So we got f of x is the quantity 3x minus 5 squared times the quantity 2x plus 7 to the 6th. Find the relative maximums of f of x and justify. Okay, so here goes. There's going to be a product rule. It's one of those weird, well, it's not weird. I mean, it's a straightforward product rule, but don't forget the chain rule. So that'll be first, derivative of the second, plus second, derivative of the first, where we did not forget the chain rule, right? So that 12 is really 6 from the exponent, 2 from the chain rule. And then the 6 that you're looking at in the second part is really a, what is it? It's a 2 from the power rule and then a 3 from the chain rule. So that's where those have come from. Now, what you want to do is group factor. You can take out a 6. You can take out a 3x minus 5, and you can take out a 2x plus 7 to the 5th. So when you do that, we end up with this because there was still a 2 and a 3x minus 5, and then there was just a 2x plus 7. So this is where we are. Then we simplify this, and we end up here. All right, so now what we do is make a sign chart. When I originally wrote the answers, my solutions, I would have gotten almost all of these wrong. I definitely got question 1 wrong because I originally thought that the 0 of 8x minus 3 was 8/3. So I had a sign chart that had negative 7/2, 5/3, and then 8/3. And then obviously my answer was wrong, disastrous. But then when I was looking it over before I recorded this, I realized, no, that should be 3/8. So I made my changes, but that was bad. All right, we got to test regions, right? So negative a billion is just going to be a negative, a negative, and a negative. So 3 negatives is this. Everything is to an odd degree, so we're going to have a sign change everywhere, which is part of why when I made my mistake previously, I had all the signs right, and I just drew the wrong conclusion because I wasn't even testing the regions. I was actually just using facts to try to get my sign chart. Anyway, we go negative, then positive, negative, positive. Relative maximums are where the derivative is going from positive to negative. So the only place that that's actually happening here is at 3/8. So I'm going to say that f of x has a relative maximum at 3/8 because f prime changes from positive to negative there. So we did it. And you didn't have to go through that with me, the mistake and the fixing, but I wanted to be upfront. It doesn't always go well. This next question, let me tell you, originally asked for the second derivative. And that is a nightmare. Finding the first derivative is kind of a nightmare. The second derivative, there's just no chance I wanted to do that. So didn't find the second derivative, just changed the problem overall so that now we're just finding the first derivative. That's the advantage I have because I'm writing the problem sets. All right, this is, I'm going to say just a quotient rule problem. It's just that the derivative of the top requires the product rule. The chain rule doesn't really kill us here because, the derivative of all the inner functions are just 1. So let's see how this goes. So f prime is going to be bottom. Derivative of the top requires the product rule. So you get first derivative of the second plus second derivative of the first. And then minus the top, which is, the given thing. And then the derivative of the bottom is just 3 times x plus 4 squared. And then all over the denominator, the bottom squared. So now it's x plus 4 to the 6th. All right, what can we group factor? So if you look at this, there's x plus 4s on both of these. You have to be really careful when you think about this because that first part, the thing that I'm calling for bottom derivative of the top, that's actually 2 terms where you have to distribute the x plus 4 cubed. So be careful with that, or actually do it. I kind of skip some steps. I don't know. So you can take an x plus 1 out of everything. So you can take an x plus 4 squared and an x plus 1 to the first out of everything. So that's what I'm going to do. And then what are we left with? Well, we're left with an x plus 4, because remember, we have to distribute that x plus 4. I really kind of screwed myself over by not distributing that. There's an x plus 4, and then there's an x plus 1, and then there's a 2 times x minus 3. Okay, so you might have to look that over a couple times to see what's happening there. And then there's a minus 3, an x plus 1, and an x minus 3. That's our numerator. And then our denominator is still x plus 6 to the 6th. X plus 4 to the 6th, sorry. We can cancel this with that, and then we're just like to the 4th. Great. All right, now what am I going to do? I'm going to like simplify a little bit here in the numerator. I'm not going to make you watch, but that's what I'm going to do. So I collected terms. So you have that x plus 1 plus 2x minus 6. I made that 3x minus 5. And then I multiplied the x plus 1, the x minus 3. And the next step, I'm going to multiply also the x plus 4 and the 3x minus 5. So here's our denominator. Let's just do that here. Collect like terms. We get this. This is in factored form. I think this is good. Could you imagine if you had to find the second derivative? First derivative is bad enough. Anyway, let's take a look at the next problem. Evaluate the limit as h approaches 0. This almost definitely has to be the definition of the derivative, right? We have like f of a plus h minus f of a over h, limit as h approaches 0. That's definitely f prime of a. So we're looking for f prime of pi over 6, where the function is sine squared. And the derivative of sine squared is 2 sine times cosine, which is also sine of 2x, but you don't really need that in this case. It's one of the double angle formulas for sine and cosine, I think, are the most important of the trig formulas in terms of calculus. So now I'm just going to evaluate this at pi over 6. So f prime pi over 6 is going to be 2. Sine of pi over 6 is 1/2. Cosine is root 3 over 2. So we end up with just root 3 over 2 as our answer, which is pretty nice. And one more problem on this problem set. Oh, and also, I mean, this is sine of 2x. So if you prefer that, you could do the sine of 2 times pi over 6, which is sine of pi over 3, and the sine of pi over 3 is root 3 over 2. All right, evaluate. The limit as x approaches a of x to the 20th minus a to the 20th over x minus a. So if I plug in a, just do substitution, I get 0 in the numerator, 0 in the denominator. I'm going to use L'Hopital's on this, and I'm going to like kind of show the correct work. So for that, you want to show this step where you're showing that both limits exist and are equal to 0, or both exist, well, or, I mean, it depends on how you view a limit, but, or that both limits are infinite. Infinite is what I wanted to say, which sounds weird. This sets up L'Hopital. So then we can say by L'Hopital's, the original limit is equal to the limit of the derivative at the top, which x is the variable, so it's just 20x to the 19th. And then the derivative of a to the 20th is 0 because a is a constant. It's not a variable. And then over 1. And then we can just sub in and get 20a to the 19th. It's also definitely possible to look at this problem as the definition of the derivative, where f of x is x to the 20th, and you're trying to find f prime of a, which will pretty obviously give you 20x to the 19th, and then plug in a, 20a to the 19th. Either way you do it, good answer. That's the whole problem set, so I hope this was helpful, and good luck.